So today we're going to be doing empty sets and identities. Now, typically what we've seen up until this point is we've seen a type of answer which we call a conditional statement. Sometimes it's true, sometimes it's not. These are typically seen when we see a conditional statement when we get something very, very stereotypical like, let's say, x equals 3. Or maybe something like y is equal to negative 15. Or you can get something where, let's say it's an inequality. Let's say w is less than 10, any number that's less than 10. Or let's say z is an element of 2, 4, 6, and 8. Any one of these values would work. If I plugged in 3, it's true. If I don't plug in a 3, it's not. Same with the negative 15. I could plug in any number that is less than 10 and my equation will be true. If I plug in a number bigger than 10, it's not. That's what a conditional statement is, and these are stereotypical for most problems that we've seen up until this point and most that we'll see after. But there are two other types that we really want to get into: empty sets and identities. An empty set is when you're trying to solve the equation and the variables disappear and you're left with something like 3 equals 2. 3 does not equal 2. So no matter what you try and plug into the variable, it won't make it true. Because again, when you're trying to solve it, the variables disappear, which means they're not relevant to the solution. What you're trying to prove is something that doesn't work. So if I say, for example, like x equals 2, 3 doesn't equal 2. If I say x equals 100, 3 still doesn't equal 2. If I say x is equal to, let's say all even numbers, 3 still doesn't equal 2. If I say x is equal to Tuesday, 3 still doesn't equal 2. No matter what I try and make, it does not work. That's an empty set. No matter what we try and plug in, the equation is not true. Conversely, an identity does the exact opposite. If I say something like 10 equals 10, it doesn't matter what I try and plug in. I could try and plug in all of these values. 10 still equals 10, which means it doesn't matter. Everything works. So without further ado, let's jump into number 1. So for the first one, we're going to solve each one of these by following the same 4 steps that we've been doing. So the first thing that I do is I distribute this 2 to both these terms on the left, so I can go ahead and simplify this. This is going to leave me with 10x plus 8 is equal to 10x plus 6. You might have seen what we're about to do right here, because what we're about to do right here is I'm about to eliminate both of these 10x's. If I subtract one of them, it's going to cancel out both of them. The left and the right go away, and I'm left with something like 8 equals 6. And so I think back to the 2 types of answers I have. Is it a true statement or is it a false statement? Well, 10 does not equal 6, or 10, 6. 8 does not equal 6, so therefore it doesn't matter what I try and plug in, it is not going to work. So I'm going to write 2 things. I'm either going to write false. Actually, I'm going to write false. This is an untrue statement. Then I have to follow it up with what is the answer set. Well, because it is false, this is an empty set, which means that there are no solutions. Or I could write the empty set symbol, which is a circle with a slash through it. Because the statement is false, these situations are true. So we don't necessarily care which one you write of those 3 statements. We just want you to know that because this statement is false, this is an empty set which has no solutions. Perfect. So let's jump off into the next one. So with the next one, we can do the same thing. We can go ahead and try and solve the equation by distributing the 2. We'll get something that looks like 11 plus 2x is 2x plus 8 plus 3. If we combine terms over here, we're left with 11 plus 2x equals 2x plus 11. And then again, we notice that the variables are equal between these two, which means if I get rid of one, I have to get rid of both. So that and that both cancel out. And I'm left with a statement like 11 equals 11. Now, unlike the 8 equals 6, this is a true statement. And because it is a true statement, we're going to call this an identity. Or we could say that this has infinite solutions. Or we could write the infinite set symbol. Or we could write the all real numbers symbol, which I guess we could write it over here, which is an R with a double bar. We don't care which one of these you write. These are all indicative on the fact that that is a true statement. So you're going to write the word true and then indicate that it is an identity which has infinite solutions. Perfect. So now that we've seen one of each type, why don't you go ahead and try number 5, pause the video, unpause it when you're done, and see how well you did. Okay, so now that you've had a shot with that, let's check it out. Perfect. So I'm going to distribute this x into both those terms, which is going to leave us with 5/3 x minus x equals 1/3 plus 2/3 x. I notice I have x's all over the place, so the first thing we're going to do is going to move this x over here. So I'm going to subtract 2/3 x. It's going to cancel that over here. And then 5/3 minus 2/3, because they're both a third, that's going to leave me with an x minus x equals 1/3. Perfect. My last thing when I combine my two x's is x minus x is going to give me a big old 0. And I get an answer of 0 equals 1/3. That's going to be a false statement, which means, comma, this is either an empty set, there are no solutions, or I could write the empty set symbol. Regardless, there are no possible values for x that I could plug in to make this equation true. Doesn't matter what I plug in up here, it's not going to be true. Okay? Likewise, go ahead and give number 7 a shot. Pause the video, unpause it when you're done, and see how well you did. Okay. So what I'm going to do is I'm going to do twice. I'm going to distribute over here and distribute over here. So on the left, 7 times 5 is 35. Divided by 7 is 5. And then I have plus 7x minus 5x. Half of 10 is 5, and half of 4x is 2x. On the left, I'm going to combine these x's right here. That's going to give me a 5 plus 2x is 5 plus 2x. I'm going to get rid of one of these variables, which means that I'm going to have to get rid of both of them. And so I'm left with a statement of 5 equals 5. Because 5 does equal 5, this is true, which means necessarily that this is an identity, or it has infinite solutions. And if it has infinite solutions, that means it has an infinite set symbol or an all real number, which is an R with a double bar. Perfect. There we go. Okay. So that is solving for empty sets and identities. What we do have down here is we have kind of like a bonus little section. We have clearing of fractions. We will cover this a little more in detail in a later topic, but the whole idea of clearing a fraction is oftentimes students don't like working with fractions. So an easy way to clear it is to go through and list each one of these denominators. We have a 5 and a 10. And we want to find the least common multiple between 5 and 10. So if you don't remember how to do that, what we do is we count by 5s and count by 10s. 15, 20, 25, 30. And I count by 10s. 20, 30, 40, 50, 60. And I find the multiple that's in both these lists that's the absolute smallest. In that case, I'm going to notice it's the number 10. It's the second one in 5, and it's the first one in 10. So I'm going to go ahead and I'm going to distribute the number 10 to my entire equation right here. So if I multiply 10 times each one of these, 10 divided by 5 is going to give me a 2. So I'm actually multiplying that by 2. 10 divided by 10 is 1. I'm multiplying that by 1. 10 divided by 5 is 2. Perfect. So what I'm doing is I'm taking d and multiplying by 2, negative 3d multiplying by 1, and 1 and multiplying it by 2. And I'm solving that equation. Now there's no more fractions. This is an easy one to solve. So let's solve this in green. So 2d minus 3d is going to give us negative d is equal to 2. In order to get rid of that negative sign, I know it's a 1. I'm going to divide by negative 1, which means that my d is equal to negative 2. Perfect. And if I jump off to the last one, I do the same thing right here. What I'm going to do is I'm going to write out all the different denominators, 4, 5, and 20, and I'm going to count in multiples of 4, 8, 12, 16, 20, 24, 28. Count in multiples of 5, 10, 15, 20, 25, 30, 35, and count in multiples of 20, 40, 60, 80, 100, 120, 140. And I'm going to find the number that's in both those lists that's the absolute smallest. And what we notice is that the number 20 is in all three of those lists. So I'm going to go ahead and I'm going to multiply all three of these terms by the number 20. And when I do that, 20 divided by 4 is going to give me 5. 20 divided by 5 is going to give me 4. And 20 divided by 20 is going to give me 1. So in doing that, I've canceled out all three of these fractions. 5 times negative 1 is negative 5. 4 times 4j is 16j. And then 1 times 11 is 11. Perfect. So I'm going to go ahead and I'm going to solve this. Plus 5, plus 5. I get 16j is equal to 16. My last step is divide by 16, which gives me a j is equal to 1. And there we go.